Here we go. So first of all, let's take a look at the question. So right off the bat, it says if cosine of x is equal to negative 2/3. Oh, hold on real quick. Let me put we're doing double angles, and half angles today. Double angle and half angle formulas, okay? So if I take a look, first example 1, let's read it. So if cosine of x is negative 2/3 and x is in quadrant 2, okay, so I'm going to build a triangle, right? Right off the bat, anytime I see quadrant, I'm going to build a triangle, find cosine of 2x and sine of 2x. So I know two things already. I'm going to build a triangle, and then I'm going to look for some formulas, okay? So let's build the triangle first. Build the triangle over here, kind of slide it over. Okay, let's build a triangle. X or theta, they like x as the angle. You can use theta if you don't like x. And then, what do I know about cosine? Cosine is the adjacent over the hypotenuse, right? And then if I want to find the opposite side, just do some Pythagoras theorem. I think that's going to help me later if I do that. So if I go 2 squared plus b squared equals 3 squared, right? I'm just going to try and find the opposite side. We'll have b squared is equal to 9 minus 4, which is 5, right? 9 minus 4, which is 5. I did a little bit in my head, but this is pre-calc, right? And so then b is going to be the square root of 5, okay? So I'm just going to put that in my triangle. Okay, so again, two things. One, let's build a triangle because we're in quadrant 2. The second thing is let's look for some formulas. So I'm actually going to do two different questions. One, we find the cosine of 2x, or you say 2 theta. So here's my cosine formulas, right? So I've got three choices. I got one with sine, cosine, sine, and one with just cosine. So now which one am I going to use? It doesn't matter. You can use all three, but this one's going to be the easiest. I'll tell you why. Why is this one the easiest? Because you already know what the cosine is, correct? So that makes this one by far the easiest. So I'm going to use the 2 cosine squared theta minus 1. So all right, here we go. So let's figure out what cosine of 2x happens to equal, right? So my formula that I want to use is the 2 cosine squared x, or theta, minus 1. That's the formula I'm going to use. They are using x. I like theta. You guys want me to change that to theta? Would that be better for you?
I mean, it'd be better if you didn't switch midway.
Right, I know. And the book does that, and they'll use all sorts of crazy formulas. They will. I like theta. So let's see. How are we going to do this? Well, fortunately, we already know what the cosine of x is, right? It's negative 2/3. So let's just go ahead and go, okay, that's going to equal 2 times negative 2/3 squared minus 1. I'm just going to put the negative 2/3 in for the cosine squared. I'm going to square it. So that answer is just going to be a 2 times a 4/9 minus 1. Okay, I'm just going to do some fractions here. 8/9, right, because that's like a 2 over 1. So I'll get an 8/9 minus 1. 8/9 minus 1 is a negative 1/8. Okay, 9/9, right? Think about that as 9/9. So you're just going to give you a negative 1/9. You guys okay with the 8/9 minus 1? You could make that into 9/9. So 1 is, so if I have a little side work, 8/9 minus 9/9, right? Because that is 1, right? Just makes negative 1/9, okay? All right, now that's the cosine of 2x. So let's find the sine of 2x. Yeah.
Why would it be minus 1?
Isn't that what the formula says? Good question, though. Julia, I don't mind good questions at all. I do make mistakes, you know that, so you should always question me, huh? So, next one, sine of 2x. Well, again, I take a look at my formulas. Then I've got the sine of 2 theta, same thing, right? And that's going to be this one, the 2 sine theta, cosine theta, right? So let's write that down. So what we're going to use is my 2 sine of x, cosine of x, right? Or thetas if you prefer thetas. I kind of like thetas better. So, all right, we already know what the cosine of x is. That's negative 2/3. The sine of x, so to find that, let's go look at our triangle, right? So if I want the sine of x, sine is opposite over hypotenuse, right? So I'll put my square root of 5 over 3 times the 2. And I'm just going to simplify this from here. So I got the square root of 5 over 3 from my triangle. And now 2 over 1, so I'll get a negative 4 square roots of 5 over 9. Okay? Question?
How'd you do that last part?
Here. So 2 times 2, because I can't multiply to the 5. 2 times 2, there's my 4, my negative 4, right? And 3 times 3. Got it? And then the 1 doesn't really matter, right? Alright, example 2. Express sine squared, cosine squared in terms of the first power. First power, which means we're going to have to take it from a squared down to not a squared. So again, I look at my formulas. Well, I've got in here, they're called lowering power. So I'm going to be able to take a sine squared and make it into a lower power. And I'll be able to take a cosine squared and make it into a lower power, right? So let's use these formulas. So first, right off the bat, we'll take a look at the sine squared. So the sine squared one is going to be a 1 minus 2 theta, but 2x in this case. So let's first of all write this one as a 1 minus a cosine of 2x over 2, because that's what the formula says. And then the cosine squared, all right, let's take a look. Okay, the cosine squared is this formula, right? X is theta. Same thing. Let's write that down for cosine. So, okay, 1 plus cosine of 2x over 2, right? All right, now, technically, it isn't a first power yet, because when I FOIL this out, I still don't have a first power. I really don't. But I am going to FOIL it out real quick. So if I do a little bit of FOILage, okay, 2 times 2, that's the easy one. 2 times 2 is 4. But on top, I'll have a 1. I'll have a positive cosine of 2x, and then I'll have a minus cosine of 2x, and then I'll have a, oops, slide this in, I'm running out of room, I'll have a minus cosine squared of 2x. Wow, that doesn't look good at all. Squished it over too much, huh? But I'm going to simplify in a second. That cancels with that, right? So what I really get is 1 minus a cosine squared of 2x over 4. How am I doing? How am I doing? Okay, it's still not reduced to the first power, so there's some more work I have to do. Okay, so before I do a whole lot, I've done this problem several times, and I've learned that the easiest way to do this problem is to break it up. Seriously, the easiest way is to rewrite this problem as a 1/4 minus a cosine squared of 2x over 4. Okay? So I made it as a 1/4, divide them both by 4. I've found it's easier, then I don't have to deal with this 1/4. I can leave the 1/4 out there and not mess with it, okay? Alright, so I've simplified this, but now I'm going to go back to my formulas. This one here, cosine squared of 2x, I'm going to have to reduce, okay? So cosine squared, let's use my formulas, cosine squared. So I'm going to use this one, right? But I already have a 2x here, so I'm going to double 2x. Okay, everybody listening? I'm going to double 2x, so I'm going to get a 4x. You okay with that? In my formula, I already have a 2x there, but when I double the 2x, I'll have a 4x. Okay, so let's see how that works. So I'm going to go 1/4, because that's my 1/4, minus. Okay, we're going to use my formula right here. So I'm going to use a little bracket here. I'm going to put my formula right down there. So my formula is to go a 1 plus cosine of 2x. So I'm going to double this. 2x. I'm going to double this. So this becomes a 4x. Okay, because I have to make that a 2x. It's already a 2x. 2x doubled is a 4x. All right. And then all over 2, right? But there's already a 4 there. Okay, so this is, it's all over 2. Just using the formula. Okay, so one more time. So it's 1 minus cosine of 2x, but we already have a 2x there, so I doubled 2x, made a 4x. So then I get to multiply this by 2, and I have a 4 on the bottom, so I get the 4 times 2. Okay, have I confused you?
Yes.
Okay. Let's see. Maybe there's another way to do this. All right, I don't want to confuse it. Let me do a little work on the board. Okay. All right, let's use thetas. Let's go this way. Cosine squared of 2 theta, right? Is going to be the formula is 1. Is it minus or plus? 1 plus 2 cosine of 2 theta divided by 2, right? There's my formula, okay? Right now, think of this as just theta, right? So that goes right there. We get 2 theta, which makes 4 theta, right? That's where I got the 4 from, okay? And then this 2 right here is on the bottom, but we already had a 4 with it, right? So this 4 times this 2 is there, okay? Does that help?
Yeah.
So now let's go from there, right? So next, what did I do with the pen? Here it is. What do I have? I'm going to have a 1/4 minus. You ready? Minus a 1/8. You see my 1/8? Minus a cosine of 4x over 8. Okay, I'll step back and see if you can see it, okay? Okay, I've got my 1/4, my minus my 1/8. There's my minus my 1/8 right there. And then minus my cosine of 4x over 8. Well, technically I've done it, but I'm going to tidy it up. Okay, technically I've got it all the way down to a first power, okay? So in a sense I'm done, but I do know that 1/4 minus 1/8 is a 1/8. You okay with that, right? 1/4. So a better answer would be to put it as a 1/8 minus a cosine of 4x over 8. And technically that's right too. You'd never mark that wrong. However, why not just make it the common denominator? And that's a better answer. So what do? We lowered both of them from squared, down to a term that's only to the first power, okay?
The cosine positive?
It becomes great question, really. You always ask the best questions. Look at you, huh? It is right here.
Okay.
Do you see right there to there? You got it?
Yeah.
I knew you would. Okay. And that's going to make it negative, right? Good question, Eli. Okay, these are kind of hard. Yes, Sarah?
Would you accept the first answer?
That one? Yeah. Yeah, but I mean, really, what's 1/4 minus 1/8? I mean, I would really like that one better, right? Because you can subtract those, right? I know you guys hate fractions, but you can do that one, right, Sarah? I know you can. Okay, ready to turn the page? Okay, these are hard, aren't they? But we can do them. Okay, now example 3. All right, find the exact value of sine of pi-8. Well, pi-8 is not on the unit circle. So if they say exact value, I think, okay, well, we've got to have an answer from the unit circle, right? Exact, got to have a unit circle answer. Well, pi-8 might be right about here, but it's not on the unit circle, right? So pi-8 is half of pi-force, isn't it? Did you go along with that? So if we have pi-force divided by 2, that would be it, right? So let me rewrite the question. Totally rewrite it so you guys can see it. So I'll rewrite this question as well. Let's call this sine of pi-force divided by 2, okay? Right? Because pi-force, half of pi-force is pi-8. Half of this, half of pi-force is pi-8, right? But I keep saying half, right? So half, I have some half formulas, don't I? What do you know? So I'm going to go to my formula sheet, and I do have some half formulas. So let's rewrite this as sine of theta is equal to, sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2, all right? In this case, my theta is pi-force, right? Which is great because I can use that and I get a unit circle answer. Now, plus or minus, which one is it? Well, it's easy. Where's pi-8? It's right here, right? So sine is obviously positive, right? So we don't need the plus or minus, just plus, right? So I'm going to just get rid of that minus, white it out, white out, not, yeah, there we go. So I don't need the minus, it is positive, so get rid of that. All right, there you go, it's gone. Now, what do we have? Well, let's plug it in. Pi-force is my theta, let's plug the pi-force in and see what we get. So I'm just going to take that pi-force, put it right there, okay? So we're going to go square root of a 1 minus cosine of pi-force all divided by 2. And if I took the cosine of pi-force from the unit circle, that's square root of 2 over 2, right? Guys, look. Pi-force, y value, square root of 2 over 2, right? So then I could have an answer of big square root of 1 minus the square root of 2.
Wait, did you get cosine is the y value?
x value. I'm sorry. Thank you. Did I say y? I meant x value. But it doesn't matter. They're the same answers, right? That's where I got lucky on that one, huh? But x value, right? Thanks, Eli. So now that is technically correct. Okay, Sarah's going to say, all right, can you take that? I would take that, yes. It is the right answer. It doesn't look very good, though. It's a fraction within a fraction within a square root, right? So let's just say that you happen to get a calculus teacher that demands and expects good answers. I did. I had several of them. It's like, so it was a pain to get the right answer. I had to make it look right, okay? So what is this going to be? So let me just show you a little simplification, all right? I'm going to make 1 into 2 over 2. Okay. Doesn't look like I've made it any better at all, have I? But then these two have a common denominator, don't they? So then I would have big square root of 2 minus the square root of 2 over 2 over 2. Now it even looks worse, doesn't it? So now I think, okay, well that's like 2 over 1, right? And I can flippy-floppy that. Do you mind if I just flippy-floppy it right now because I'm running out of room? So I flippy-floppy that. Remember we invert and multiply? How am I doing, okay? So then if I were a calculus teacher, I'd say, okay, this is getting closer to a better answer. I'd have the square root of 2 minus the square root of 2 over 4. Okay, so I'd have 2 minus the square root of 2 over 4. And then somebody would say, oh, Mr. Davies, can't you take the square root of 4? Come on, somebody. Hey, Mr. Davies, can't you take the square root of 4, right? Why not? What's the square root of 4? So in my calculus class, I would love this answer there. Now, of course, Sarah, go ahead and ask it. Would I take that answer? Yes. That's a better answer. But it's still a square root within a square root, but you can't do anything about that. But there are no square roots in the denominators, right? Okay. Okay. Thumbs up. Sideways. Okay, this is kind of hard. All right. Let's do example 4. Okay. All right, so example 4. Tangent of x over 2. Sine is 2 over 5, and x is in quadrant 2. Okay, so first of all, let's build a triangle. Anytime you see quadrant, right, build a triangle. So we go over and make a triangle in quadrant 2. And I know sine is opposite over hypotenuse, right? And if I want to find the adjacent side, I'm just going to use Pythagorean's theorem, right? So I'm going to go, okay, a squared plus 2 squared equals 5 squared, right? I need to find the adjacent side because I need to complete the triangle. Here's my angle x. So a squared plus 4 equals 25, right? A squared equals 21. A is equal to the square root of 21. And not a very nice number, but it'll be okay. So but square root of 21 here, except I make it negative. Why do I make it negative? It's going that way. Very good. See how much math you guys learned. You actually have learned a lot of math, haven't you? You're getting good at it. So now let's go ahead and figure out what we got to do. So tangent of x over 2. So I'm thinking, okay, I'm going to need a formula, right? So I'm looking at my formula sheet. How about tangent of theta over 2? Now you've got two choices. It does not matter. You've got this one or this one. I kind of like the top because I like the top formula better because I like the sine on the bottom. It's just instead of 1 plus cosine. It's probably going to be simpler if I've got just a single thing on the bottom. In case I have to rationalize or something crazy on it. So I'm going to use the top formula. I'm going to use the 1 minus cosine theta over sine theta. Okay? It's going to get easy. It really is. So I go to my triangle. 1 minus cosine of theta. Cosine's adjacent over hypotenuse. So then I get a minus square root of 21 over 5. Because that's cosine, right? Adjacent over hypotenuse, right? All over the sine. And of course the sine's opposite adjacent or opposite of hypotenuse, so it's just 2 over 5. Well, that's kind of a mess, but we're going to fix this one real quick. Man. So let's fix this thing. So first, I'm going to go with a 1 plus the square root of 21 over 5. How about we flippy floppy? You guys okay with flippy floppy? Invert and multiply. 5 over 2. Just flip that, right? And if I distribute, okay? If I distribute this times this times this, right? I'm going to get a 5/2 plus 5's cancel. You okay with that? 5's cancel? 5 square root of 21 over 2.
So can you cancel the times before you multiply it?
Well, you can't because you got to still multiply it to the 2. Great question, right? Because then you'd lose it for this one, right? And then how about this answer? Since they have a common denominator, have 5 plus the square root of 21 over 2, okay? How's that? Not a lot of problems. 1, 2, 3, 4, 5, 6 problems because they're hard, aren't they? Right? They're hard. And I will do them with you. You guys want me to do them with you again?
Yeah.
Okay. So 5, 61, 7, 9, 26, 29, 30, and 38. And let me go ahead and put it online.